Okay, this is lesson 5.1, working with bisectors of line segments and angles. Your job today is to take notes on this video using your notes packet and your own sheet of paper. And then when I pause, not when I pause, but when I ask you to do a problem or when I demonstrate a problem, you'll either take notes about that or attempt the problem on your own. And at the end of the day, you will show me your work to prove that you've been working along with the video and attempting the problems. Take a moment to pause the video, get out your vocab sheet, and record the definitions for equidistant and locus. Now, the perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of a segment. So you can either find this in your book or you can pause the video now to kind of read that definition over again to yourself. And then the converse of that says if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector of the segment. And again, you can either read this in your book or pause the video now to absorb this. Let's look at it. So the line segment that we're talking about is this purple line segment right here. And then we have the green line, which is perpendicular to it. Okay, and we know it's perpendicular because it's making a right angle, two right angles with this line segment here. If it's a bisector, then it should split this line segment into two equal parts. Let's make sure that it does that. Yes, the purple line is split into two equal parts. Each side is the same length as the other side. And then what we also know is that from each endpoint of the purple segment, it should be the same distance from one endpoint up to a spot on the perpendicular bisector as it is from the other endpoint up to the same spot on the perpendicular bisector. So from B to X should be the same distance as from A to X. Let's double check that that is true. Yes, they are the same length. So now we're going to use what we know to find the measure of NM, the line segment there. Well, we know that this line P is a perpendicular bisector, first of all, because of that right angle there, and then because it's split the base of the triangle ML into two equal parts, which we see from the tick marks. So then from the endpoints, from L up to N, should be the same distance as from this other endpoint M up to the same spot N. So if this length is 2.6, then the other side of the triangle that it's forming should also be the same length, should also be 2.6. Pause now to record this in your notes or on a separate sheet of paper. Now let's find each measure here. So we have this line segment BC, and then perpendicular to that is the line that goes DA. Perpendicular because of the right triangle. Now from the endpoint B up to the point A on this perpendicular line is 38, which is the same as from this other endpoint C up to the same point A, 38. So since these two lines here are equidistant, we know that line DA is bisecting the line segment BC. So if one side, one half of BC is 12, then the other half of it should also be 12. Find each measure here. All right. Using what you know, you see that line UW is perpendicular to TV and that it's splitting it into two parts, must be a perpendicular bisector. So what do you know about these two sides? So go ahead and set those two sides equal to each other. 3x plus 9 equals 7x minus 7. Solve for x. And when you get x, plug it back in here and here. Pause the video now to attempt this problem. Try out this problem. Knowing what you know, try it out. And they tell you that EG is 14.6. Okay, so let's get that filled in your diagram. EG, that distance there is 14.6, and they want you to figure out what is DG, so figure out what is this length here, if you can. Now in your book you'll see this little chart where you can pause the video now to read this, but now we're going to talk about angle bisectors. So when we have an angle bisector, we've got this big angle, the angle made from the two red legs, and then we have this blue line which is bisecting the big red angle. How do we know it's bisecting it? Because it's splitting it into two equal parts. This little angle is equal to that little angle. The big red angle has been split in half. Okay, so then from the side of the angle perpendicular up to a point on the blue bisector, this should be the same length as from the other side of the big angle perpendicular up to the same point on the blue bisector. We know we have to go perpendicular from this line up to that point on the blue bisector because the shortest distance from a line to a point is perpendicular to that line. And so we can check, is from here to this point on perpendicularly up to this point on the bisector the same as from here perpendicularly up to the point on the bisector? Let's find out. Sure is. So now we need to find the measure of BC. We're finding this measure here. Well, we know that this big angle BAD has been bisected into two equal parts, so it's bisected. And when we go from here on the one side of the angle perpendicularly up to a point on the bisector, it should be the same from the other side of the angle perpendicularly up to that same point on the bisector. So if this from D to C is 7.2, then going from B to C, going from here to here should be the same length, 7.2. Put that in your notes. Given that angle, find the measure of EFH. So find the measure of EFH, given that the whole thing, EFG, is 50 degrees. So given that that whole thing is 50 degrees, find just this little angle right here. Well, we know that from one side of the big angle perpendicularly up to a point on this line is equal to the other side of the angle perpendicularly up to the same point on that line FH. So we know that this line FH is bisecting EFG. So if the whole thing EFG is 50 and that's been bisected, then 50 degrees should be split into two parts or divided into two parts. So each little angle should be 25 degrees. So EFH is 25 degrees, and you could also say that GFH is 25 degrees. Find the measure of angle MKL using what you know. Solve for A, and then plug A back in to get the measure for MKL. All right. Given that the measure of angle WYZ is 63 degrees, so this is 63 degrees, XW is 5.7, and ZW is also 5.7. They want you to figure out what's the measure of angle XYZ. So what's the measure of the big angle if just this little one is 63 degrees? Figure that out on your paper. All right, this final one is a long problem, and you're going to use things that you learned in Chapter 3 having to do with slope, midpoint, perpendicular. You're going to try to figure out what's the equation in point-slope form for this perpendicular bisector. So here are some things you need to remember. Point-slope form is written in the format y minus y1 equals m. M is slope times x minus x1. Okay, good. Then the next thing you're going to need to do is you are going to need to figure out what is the slope of the line segment that goes from here to here. All right, and so then your formula for slope, remember, is m equals y2 minus y1 over x2 minus x1. And then when you get the slope of the original line segment from this point to this point, then figure out what's the perpendicular slope. And remember that perpendicular slope is the negative or the opposite reciprocal. So you'll have figured out the original slope, then you'll figure out the perpendicular slope, and then you're going to need to figure out what is the midpoint between C and D, so that way you can figure out what is a point on my perpendicular bisector. So then your midpoint formula is x1 plus x2 divided by 2. And then the other coordinate is y1 plus y2 divided by 2. So then you'll have a midpoint. And then once you have a midpoint, you will use this midpoint to fill it in here. So you'll go y minus whatever this y was equals m, that's your perpendicular slope, times x minus whatever you get for x here. Good luck. Raise your hand if you have questions. This is the last problem that I need to see in your notes. Thanks for watching.